Hello Godotneers! Did you ever want to create nice visual effects for your game? Then you probably have stumbled upon Godot's particle systems. And maybe you were a little bit overwhelmed by all the settings and features that Godot's particle system nodes provide. So we are going to explore how particle systems work and how to configure them so they produce the effects that we want. We're also going to look into how we can let particles interact with our world, how we can produce interesting effects like water splashes with particle sub-emitters, how to use particle animations to make our particle systems look more realistic, and how to create effects with particle trails. This is a beginner level tutorial. To make the most out of it, you should have a basic understanding of Godot's core concepts like nodes and scenes. If you want to follow along, you can download a copy of the project that we use in this video from GitHub. You can find a link to this project in the description of the video. So we're in Godot, and to get started, let's make a very simple particle system. We have a little 2D scene here with two portals and Mr. G. If Mr. G walks through a portal, he will be teleported to the other one. The two portals look a bit boring, and we would like to spice them up with some nice particle system. The portals have their own scene, so let's open up the portal scene. And right now, the portal is really only a static sprite, so there's not a lot going on. We're going to add a particle system node, and we're going to add this as a child to our portal sprite here, so it is at the center of the portal. So let's first select our portal sprite, then press Ctrl A to add a new node, and then let's search for particles. And here we have two options for creating the particle systems, a GPU particles 2D node and a CPU particles 2D node. Both of them work in a similar way, but the CPU particles 2D node is intended for older PCs, and it has less functionality and is no longer getting any updates. So we are going to use the GPU particles 2D node for our project. Now we have a shiny new GPU particles 2D node in our scene, but it doesn't seem to do anything. There's a small warning sign on this node, so maybe this gives us a clue. The warning says a material to process the particles is not assigned, so no behavior is imprinted. To understand what this warning means, we first need to understand how particle systems work in Godot. In 2D, particles are small sprites that are spawned by the particle system, and each particle has a lifetime. During this lifetime, the particle system will animate the particles, and we have a lot of options that allow us to control how exactly this animation is going to look like. When the lifetime of a particle ends, then the particle will just disappear. When we use a GPU accelerated particle system, then all of this is controlled by a so-called particle shader. And this may sound scary, but Godot provides a built-in particle shader, a so-called particle process material, so we can control the particle system without writing any shaders. So the error message here tells us that we do not have yet assigned a particle shader to our particle system, and therefore the particle system will not work correctly. So let's go over to the inspector here, and we have a setting called process material. And if we click here, we have two options. One is a shader material, and the other is a particle process material. And for this video, we're going to use the particle process material. If we now zoom into our particle system, we can see that it actually spawns some particles. But they are really hard to see against the portal backdrop, so it would be nice if we could fade out the portal a bit so the particles are a bit more visible. Cannot hide the portal sprite because that would hide the particles as well. So let's select the portal sprite, and then we go down here to visibility and use the self-modulate setting to make the portal a bit translucent. So we drag the alpha down, maybe to 40, and now we can see the particles much better. It's important that we do this on the self-modulate here, because if we use the modulate, then our particles would also become translucent. Now we can see our particles, so let's see how we can use some of the options of this particle system to make some interesting visual effects. We have quite a lot of options. We can control how the particles move, how they accelerate, how their visuals change over time, how they collide, and a lot of other stuff. These really can be a bit overwhelming at the beginning, but lucky for us, Godot has some really good documentation on what each of these features do. The documentation even has some nice animations, so we can see what is actually going to happen when we change a setting. You can find a link to this documentation down in the description of this video. So right now we only have these small squares that seem to fall down. And first, I'd like to have something different than a square. We can control how the particles are going to look like by changing the texture setting. And we can use any texture that we like. So if we use the default texture that comes with the project, well, our particle system now spawns Godot robot faces. It looks a bit funny, but it's not really the look I'm going for here. So let's try something different. Maybe this blob texture here. Okay, this looks a little bit nicer than the squares, but this is supposed to be a portal, so these particles should not be falling down. They should move away from the center of this particle system in all directions. How can we do this? Let's first try to get rid of this falling motion. So if we look through the documentation, we can see that there is a setting that allows us to control gravity that is applied to the particles. And we can find the gravity setting here in the acceleration section. So let's set this to all 0 so that no gravity is applied to our particles. And this makes the particles stop, but they are still not moving away from the center. There seems to be a setting here which is called radial acceleration, which could maybe help with that. Let's try to enter a 10 here and then let's see how that works. Okay, this does exactly nothing. So why is that? Well, the radial acceleration feature needs to know into which direction the particle should move. So it looks where is the particle right now and where is the origin of the particle system, and then it can calculate the direction in which the particles should move in order to move the particle away from the origin. But if we look at how our particles spawn right now, we can see that all of them spawn exactly at the origin of the particle system. And because of this, the particle shader cannot calculate a direction for the particle. To fix this, we need to spawn our particles a bit away from the origin, ideally in some small circle. So let's go to the spawn settings, and here we have a setting called Emission shape. Right now it's set to point, so all particles spawn at a single point. Let's change this to ring, because we want our particles to spawn in a ring around the origin of the particle system. Now it looks that our acceleration setting actually can do something. We can also set the size of the ring. So if we set this emission ring radius setting to maybe 100, we can see that the particles now spawn over a much larger area. There's also an inner radius which we can set to make an actual ring shape. So if we set this to say 90, then no more particles will spawn in the middle, and we get an actual ring shape. There are also a lot of other settings, but if we want to go through all of them, then this video would be 5 hours long, and they're all described pretty well in the documentation. So let's set the radius back to 1 and the inner radius back to 0, and then move on. Now our particles really quickly die after they have spawned, and that doesn't look too good. So let's fix that next. We can go down here to the lifetime setting, and we can change the lifetime to, let's say, 10 seconds. Now we are getting somewhere, but we need a lot more particles than these. So let's move up here and increase the particle amount to, say, 400 particles. Yes, that looks a lot nicer. But it doesn't really look that interesting. So how can we make it more interesting? A good way to make particle systems look interesting is to make sure that not all the particles look the same all the time. Right now, all the particles are just white blobs, and this is what makes it visually not very interesting. So maybe let's try to randomize their size. If we go here to display, we have an option to randomly scale our particles. So let's try a minimum scale of 0.2, and let's leave the maximum scale at 1 for now. Well, that is definitely an improvement, but it's still kind of static, and it would be nicer if we were able to change this size over time, so we get some kind of glittering effect. We can add a curve to this scale setting, so the scale changes over time. So here on the scale curve setting, we can create a new curve texture. And now we can draw a curve that controls how the particle size changes over the lifetime of the particle. So here on the left, we can say what the size should be when the particle comes to life. And here on the right, we can say what the particle size should be when the particle is at the end of its lifetime. And we can also have as many points as we want between the start and the end of the curve. The value of this curve will be multiplied with the base scale of this particle, and this way the particle will change its size. So to get some kind of glittering effect, the particles would need to change their size all the time. So let's add a few more points to the curve, so the particles get bigger and smaller and bigger and smaller and so on. And this looks a lot more interesting. Nice! Now it would be good if we could limit the range of the particles so they stay inside of the portal. A very quick way to do this would be to use Godot's clipping feature. So we can select our portal sprite, and then we set its clip children setting to clip and draw. This somehow also makes our particles translucent, so let's remove the self-modulate from our portal sprite for now. And now the particles are clipped at the outside shape of our portal. But I think that doesn't look very nice. It would look nicer if a few particles actually made it to the outside. So let's disable the clipping feature and try something else. Maybe we can get a better result by tweaking the particle lifetime. If we reduce the particle lifetime, then the particles should leave the game earlier, and this way they should not have the time to leave the area of this portal. So maybe let's try to reduce the lifetime to 4 seconds instead of 10. And we need to wait a bit. And this is closer to what we want, but now the particles don't reach the upper and lower parts of the portal because they die too soon. The particles move at the same speed in all directions, so they sort of form a circle shape. But if we could get the particles to move a little bit faster in the up and down direction than they move in the left and right direction, then they would form some kind of ellipse that is closer to the shape of our portal. So how can we do this? When we look at the acceleration settings, we only really have the option to increase or decrease the acceleration, but we cannot say we only want to increase the acceleration on the y-axis. So there's nothing here that would help us, but maybe we can find something useful at the velocity section. Here we have a section called directional velocity, which sounds promising. This has a velocity curve setting, and we can add a curve XYZ texture to that. So now we have curves which change the velocity of this particle for each axis, X, Y, and Z. We want to change the velocity for up and down, so we are going to add a curve to the curve Y setting. Let's start with cranking the curve up to 1 and see how that works. Well, that doesn't seem to do a whole lot, so maybe we need to increase the velocity setting up here. Well, let's go with a min velocity of 15. And now that seems to be doing something. Our particles now move into the down direction, but we also want to move them up. So let's try to set the minimum velocity to -15 and the maximum velocity stays at 15. So we should have a few particles going up and a few of them going down. And that looks a lot better. But the particles now form some kind of vertical beam. And we have not so many particles here in the center part, left and right from the origin. So maybe we can fix that by saying that our particles should have a bit of time to move left and right. And once they have moved a bit left or right, only then they can start to move up and down. And we can do this with this curve. We can just add a second point, and then we say, okay, at the beginning of the particle lifetime, the y velocity should be lower. And then over time, the y velocity should increase. And we can tweak this curve a bit until it looks about right. And that is a thing in general with particle systems. They require a lot of tweaking, looking at stuff, and getting a bit creative to get the look that we want. Okay, that looks halfway decent, so let's try how this looks in the real game. So we go to our test scene, and then we hit the play button to start our game. And we can immediately see a problem. Our particle systems need some time to get started, so our portals look kind of ugly before the particles kick in. How can we fix that? Well, let's go back to our portal scene and then let's select the particle system. And we can go down to the time section. And here we have a setting called pre-process. And if we hover over this, the help text says, particle system starts as if it had already run for this many seconds. But this sounds pretty much like what we need. So let's crank this up to maybe 30 and see if this helps. We start the game. And now the particle systems are in full spin immediately when the game is started. Great. So the particle system really improved our static portal sprite, but the borders of the sprite still look a bit static. So it would be nice if we had some additional effect there. For example, we could have particles spawn at the border of the sprite and then move towards the center, so it would look like they are sucked into the portal. So let's try this. And to speed things up, let's duplicate the particle system we already have. So Ctrl D to duplicate the node. And now we have a second copy. Let's name the first one sparkling particles and the second one maybe border particles. Now we want the border particles to spawn along the border of our portal sprite. Let's go to spawn position and then let's increase the ring size. We can look at the rulers in our editor and see that the portal has a radius of about 50 pixels. So let's set the emission ring radius to 50 pixels and the inner radius to something that is a bit smaller, maybe 48 pixels. Okay, this gives us a nice ring, but wait a minute, what happened to our sparkling particle system? This also now uses this new emission ring radius. What's going on here? Well, when we duplicated the node, the particle process material that this node was using was actually not duplicated. So now our sparkling particles and our border particles share the exact same process material. So if I make changes in one, then the other will change with it. And that's not what we want. So let's first set the radius back to 1. And then we want our border particles to have its own copy of the particle process material. To do this, let's right-click here on the process material and select Make Unique Recursive. Now this dialog shows up and it tells us what will be duplicated. So it will not only copy the particle process material, but also copy the two curves that we have created for our velocity and scale. Now let's click OK, and now both particle systems should have their own copy of the process material, and changing one should not change the other anymore. Okay, so let's now set the emission ring radius back to 50 and 48, and our little ring shows up. It's a bit difficult to see what's going on, so maybe let's hide our sparkling particles for now. Now we can see the ring, but we actually don't need a ring, but rather an ellipse. So it looks like the particles spawn at the border of the portal. We can get an ellipse if we scale the ring. If we double its size on the y-axis, we should get an ellipse. So let's go up here to the emission shape scale setting and put in a 2 in the y-axis. Let's wait a bit. And that seems to be not enough, so maybe let's go with 2.2, and that is better. But this is a somewhat tedious process, and what would we do if we have a shape that is not an ellipse? Maybe even something really complex like text. Well, we can let Godot make an emission shape from a texture. If we go up here in the editor and click on this GPU Particles 2D button, we get a pop-up menu with some options. And one of the options is Load Emission Mask. Let's click on that now, and a dialog will open up where we can pick a texture. Godot will look at this texture and then create a shape based on what the texture looks like. We want the shape to look like our portal, so we go to the portal folder and pick our portal SVG file, and then we press Open. And now we can set up a few options. First, we have this emission mask setting, and here we have 3 options, and these are explained very nicely in the documentation, so let's have a look at them there. If we pick solid pixels, then the particles will spawn everywhere except where our texture is transparent. This is not really what we need. If we choose border pixels, then our particles will spawn at the edges of our texture, and this looks like the one we need. We also have directed border pixels, which is similar, but lets the particles move away from the border. We don't really want that, so let's use border pixels. Now we also have an option to center the emission shape around our particle system. And we want to do this because our particle system is in the center of our portal. So let's check this option. And the final option would use the color of the pixels in our texture to color our particles, but we don't need this, so let's keep it unchecked. Then let's press OK and have a look at what this did. We can see that Godot changed the emission shape to points, and it generated some texture which has information about our emission shape in it. But the generated shape does not seem to fit our portal. Why is that? Well, we still have the 2.2 scale on the y-axis in our emission shape settings, so we need to change that back to 1. Wait a bit. And now the shape fits perfectly onto our portal. Now we want these particles to be sucked into the portal, so let's first clean up any motion that we have copied from our first particle system. So let's remove the directional velocity here, and let's also remove the radial acceleration here. And now we can set up the motion that we want. We can again use radial acceleration for this, but because we want the particles to move towards the center, we use a negative radial acceleration. And let's also set the maximum to a -10. And that looks like it could work. I think the sparkling thing that we did for the first particle system doesn't work as well on this one. And it would look nicer if the particles started big and then got smaller and smaller as they move towards the center. So let's try to build that. We go to the scaling settings here on the display. And here we have the curve that we have copied from the sparkling particles. Let's use the linear preset. And now we can see that the particles start small and become bigger as they move towards the center. But we want it to be the other way around. So let's drag this point up to 1 and the other one down to 0. And that looks better. I also don't like how these particles pop in, and I think it would look nicer if they slowly faded in at the beginning. So let's go down here to color curves, and in here we have a setting called alpha curve. And with this setting, we can change the transparency of our particles over time. So let's create a new curve texture, and inside we add a new curve. And now we can set up how the transparency should change over time. At the start, our particles should be fully transparent. So we set this first point of our curve to 0. And now we add a second point and drag that to 1. So our particles will slowly become less and less transparent. And this got rid of the popping, really nice. Now we can do a few more tweaks. So first, I think we need a lot more particles. So let's crank the particle count up to maybe 1000. Okay, that is better, but we still have a lot of the border that is visible all the time. So let's try to increase the particle size. We currently have this randomized between 0.2 and 1. So let's maybe go with 1 and 2. And maybe let's also scale the particles down a bit earlier so they don't reach the center. So here at our scale curve, we can drag this right point more towards the middle. And now the particles will scale down faster. And finally, let's enable the clipping again for our portal sprite so that the outer part is clipped away and we get a nice crisp border. Let's turn on our sparkling particles again. And this looks quite nice, but our sparkling particles are now clipped as well, and we don't want that. So let's move them below the portal sprite so they draw on top of it and they're not clipped. This works very nicely. So let's go back to our main scene and let's see what else we can do to make it look more lively. Maybe let's add some rain to our scene so it gets a little bit more atmosphere. We start by creating another particle system. So Ctrl A to add a new node. And we choose another GPU particles 2D node. Let's name it rain so we keep things nice and organized. And now we can add a process material. And as a texture, we use this drop texture here so we get little raindrops. Then let's move it up here in the middle so the rain comes from the sky. Now we want this particle system to spawn particles across the whole width of the screen. So we go to spawn and then position. And from the portals, we already know that we can set up a shape here in which the particles should be spawning. Let's see what shapes we have available. And I think box is the one that we want. Now we get some setting down here, Emission box extends, where we can set up how big the box should be. This setting is in world units, and in 2D, world units are the same as pixels. For this project, I have set up the screen width to be 1646 pixels, and I want the rain to go over the whole width of the screen, and maybe a little bit extra. So if we set the X extends setting to, let's say, 900, then we get 900 pixels to the left and 900 pixels to the right, and that should cover our screen. Because our rain spawns off screen, we don't really need to change the Y setting here, so all the rain particles will spawn in a line that is about 1800 pixels wide. Now we need a lot more particles, and they should probably also live a bit longer so they can actually reach the bottom of the screen. So let's go with maybe 800 particles. And we let them live for about 5 seconds. And that looks like we're getting somewhere. But the drops are falling a bit too slow, so this looks more like snow and not exactly like rain. So maybe we should give them some initial velocity so they already have some speed when they spawn, and then it hopefully looks a bit more like rain. If we go here to the velocity setting, we have quite a few options to set this up. We set our initial velocity to maybe 600. And now this looks very funny. All our particles are going a bit to the right, and they also kind of spawn upwards, which is not really what we want. We can fix this by combining these direction and angle settings that we have here. Right now, the direction is set to 1 on the x-axis and 0 on all other axes. So the particles will move to the right. And then we have this spread setting, which makes the particles spread out 45 degrees in the direction they are spawning. So let's first decrease this setting to 0 so the particles don't spread out anymore. And that looks a lot better, but they are still going to the right, and we want these particles to go down. So we need to change this direction setting so it points down instead of right. So let's set x to 0 and y to 1, because positive y is down in Godot, and this looks a lot better. I think I still like to keep a little bit of movement to the right, so it looks like the rain is blown by the wind. So maybe let's add a tiny bit of movement on the x-axis, maybe 0.1. And this is a nice basic setup, but we still need to make it more interesting to look at. So we need to add a bit more variety to our particles. And one thing we can do is to give the particles different initial speeds, so some fall a bit faster than the others. Let's set the maximum initial velocity to maybe 850. This is really nice. This kind of gives a 3D effect, so let's keep that in. Now it would also be nice if our raindrops would not have all the same size, so let's use the scale setting again. And let's maybe go with a minimum scale of 0.2. And that looks a lot better. Also, let's maybe make the particles a bit transparent so they blend nicer with the rest of the environment. For this, we can just use the modulate setting down here. And then let's set the alpha to maybe 120. And of course, we can tweak this forever, but I think that looks okay for now. So we're going to cut it here. Let's start the game and see if it actually looks okay in the game as well. And our rain is not visible in our game. Why is that? If we go back to the editor, we can see that there's a little rectangle around our particle system. And this rectangle controls whether or not we see the particles that are emitted by this particle system. So if this rectangle is visible on screen, then we see the particles. But if I drag the screen a little bit, so this rectangle is no longer visible, then the particles will also disappear. And this is pretty useful in general because particle systems will disable themselves when they are not visible on screen, which helps with the performance. But in our case, we actually want the rain to be going even if the source of the rain is currently not visible on our screen. We can fix this by just increasing the size of this rectangle so it will always be visible. So let's change its size to be 1800 by 900 pixels, and let's also move its position to -900 and 0. And now this rectangle covers the whole screen and it should be visible at all times. Okay, let's start again and see if this fixes things. And now we can see the rain. But we have the same problem that we had with the portals. The rain is only starting when we run the game, and we don't want that. We already know how to fix that, so let's go to time and then set the pre-process setting to maybe 10 seconds. Let's start the game again, and this looks pretty nice. Except that our rain falls to the ground, and we don't want that to happen. But why are the particles actually going through the ground? If we hide the ground, we can see that we have a collider here. Otherwise, Mr. G would just fall through the ground as well. So why does this collider not block our rain? The reason for that is that particle collisions are not calculated by Godot's physics engine. We can have thousands or even hundreds of thousands of particles, And calculating all these collisions within the physics engine would be just way too expensive. So Godot uses a simplified system for calculating particle collisions, and this means that particles will not react to any kind of physics collider. So how can we make our particles collide with the ground then? For 2D particles, we can use a light occluder 2D node. So let's press Ctrl A and then add a light occluder 2D node. And then in the inspector, we add a new occluder polygon 2D. And now we can draw a shape for our light occluder. So let's quickly add a few points. So our occluder covers the ground. And that should about do it. Okay, that is done, but our particles are still going through the ground. Why is that? Well, we need to tell the particle system what should happen when a particle collides. So let's go back to our particle system, and here under collision, we can set a collision mode. Right now this is set to disabled, and this means that our particles will not collide with anything. So let's try the other collision modes. We have one that is called rigid, and this lets the particles float on the ground, which is not exactly what we want. So let's try the second one, which is called hide on contact. Okay, this mode lets the particles disappear once they collide with something, which is exactly what we want for our ground. And there's a small problem though. It looks like our particles are only disappearing once they are inside of the ground. And this doesn't look too realistic, so how can we fix that? There's another setting down here in the collision section named base size. And if we hover over this, then it reads multiplier for particles collision radius. If particles appear to sink into the ground when colliding, increase this value. So let's increase this value until the rain looks about right. And about 5 looks good for me. Great, so now we have rain that can collide with the ground, but it would actually be nice if we would see some kind of splashes when the rain hits the ground. So let's first make a small particle system that will be our splash. We press Ctrl A to add a new node, and we create another GPU particles 2D node. And let's call this one splash. And let's also move this down to the ground so we can see how it's going to look when it's near the ground. Now we add the drop texture as well, and we add a new particle process material. Now, how should this splash look like? Well, we want to throw some water droplets up in the air, and then gravity should pull them back down, so it looks like a splash. Well, let's start with the part that pushes the particles up. So we go to spawn and velocity, and we give it some initial velocity upwards. So we set this direction to 0 on the x-axis and a -1 on the y-axis, because -y is up in Godot. We also need to give the particles some initial speed, and let's maybe go with something between 30 and 40 units per second. Now our particles really are too big, so we need to scale them down. Let's go down to the display section, and under scale, let's make them smaller. Maybe let's go with a minimum scale of 0.1 and a maximum scale of 0.2. I think the splash could be a bit stronger, so let's go back to the initial velocity and crank it up a bit so it's between 50 and 60. Now we can use this spread setting to change how our particles would spread out. If we make it a bit wider, then the particles will spread out more to the left and the right, and if we reduce the spread, then our particles will go a bit higher, but not spread out so much to the left and right. And I think something around 20 works nicely here. Now if we look at our drops, they move a bit strangely. Usually the thick end of the drop should always point into the direction into which the drop is moving. Well, let's see how we can fix this. We have an angle section here where we can change the angle of the particles. So let's start by changing the min and max angle to 180 degrees. And now the drops look okay while they go up, but when they move down, they should turn 180 degrees. So maybe we can use a curve again to change their rotation over the lifetime, similar to how we changed the size of our portal particles. This curve has some defaults of -360 to 360, which are not very useful because this curve is going to be multiplied with our angle setting up here. So let's reset the min and max values back to their defaults of 0 and 1. And now we can use a preset to get some starting point. So let's go with the linear preset here. And if we look at the drops, this is exactly opposite of what we want. The drops start pointing downwards, and then when they are at the top, they turn around. So let's change this curve. So we want the particles to start with 180-degree rotation at the beginning. And at the end of their lifetime, we want the particles to be back to a rotation of 0. Now this is closer to what we want, but only the drops on the right side look okay. The ones on the left side should actually turn the other way around. So it looks like using this curve and the angle setting is not going to help us. So what else can we do? Well, let's first revert all of this. We set the angle back to 0 and remove the curve. And now there's another setting that can help us, and it is hidden up here in the particle flex section. There's a setting called Align Y, and if we hover over it, the description reads, align y-axis of particle with the direction of its velocity. Now that's a bit fancily written, but it basically means that this setting will rotate the particle so it points into the direction it is moving. So let's enable this. And now our drops turn into the right direction. Nice. Now there's one more thing. Our particle system currently more looks like a little fountain rather than some splash. And this is because it creates the particles slowly one by one. But when the drop hits the ground, all of the splash drops should spawn at the same time. How can we make this happen? If we go down to the time section of the particle system, we have a setting called explosiveness. And if we increase the setting to 1, then all the particles will spawn at the same time. This looks a lot more like a splash of drops. We can still endlessly tweak this, but let's cut it here for now and see this in action. So how can we spawn this particle system whenever one of our raindrops hits the ground? To do this, we need to add this splash particle system as a sub-emitter to the rain particle system. So let's select the rain particle system, and here in the sub-emitter setting, let's select the splash particle system. But we still don't see anything happening, so what is wrong here? Well, we still need to tell the rain particle system when it should use its sub-emitter. So let's go into the process material and there into the sub-emitter section. Here we can set a mode for how the sub-emitter should be used. We have 4 settings here, but unfortunately they're not documented. So let's look at each setting and see if it does what we want. We have disabled, which will do nothing. We have constant, which will run this sub-emitter at a constant rate, like 4 times a second. We have at end, which will run the sub-emitter at the end of the particle life. And we have at collision, which runs the sub-emitter when the particle collides with something. Okay, but I still don't see a lot happening here, except, well, there are some splashes showing every now and then, but we should have a lot more of them. Maybe if we increase the amount here to 16. Well, still not a lot. So what is going on here? We can find a clue when we hover over the amount at collision property. The documentation says this value should exceed the amount defined on the sub-emitter node. If the number of particles is exceeded, no new particles will spawn until enough particles have expired. So it looks like that sub-emitters work a bit differently than I expected. When a particle hits the ground, our particle system will not create a new sub-emitter and let it run, but instead it will ask the sub-emitter, could you please spawn some particles at this location? And then the sub-emitter will spawn some particles at the given location, but this sub-emitter has a maximum amount of particles that it will spawn overall. And if this amount is reached, then no new particles will spawn until some old particles have expired. So to fix our problem, we need to crank up the maximum amount of particles on our splash sub-emitter. But to how much? Well, we can do a little back of the envelope calculation here. Our rain particle system currently has 800 particles, and when the rain hits the ground, we want to spawn 8 splash particles. And that's 800 times 8, which is 6400 splash particles. And now a lot more is going on. That actually might be a bit too much, so maybe let's decrease the amount of splashes when the rain hits the ground. So let's go back to the rain particle system and change the amount on collision to 4. Now that's better. Let's also make our splashes a bit transparent like we did with the rain. So we select the splash particle system. And down here in visibility, we change the modulate setting and set the alpha to about 120, like we did for the rain. And again, we can endlessly tweak this until it looks just right, but for now, let's move on. Meanwhile, the rain has stopped and Mr. G has made a little fire. I've created the fire and the smoke using the same techniques that we have used so far. If we look a bit more closely at the smoke, we can really see that this is just a static image of smoke being duplicated a lot by our particle system. How can we make this look a bit less static? If we look at our smoke particle image, we can see that it has quite a bit of detail, and we would need a very large amount of very small particles to get this amount of detail. We would also have to run some gas or fluid simulation to get a visually interesting result. And this is something that takes a lot of computation time, and we cannot really do this in real time with the hardware that we have right now. So if we cannot get this simulation done in Godot, can we still make a good-looking smoke? Well, we can create such a simulation in an external program like Blender or Houdini, and then create a sprite sheet from this simulation. We can then import this sprite sheet into Godot, and it would look something like this. There are also ready-made sprite sheets available online, and if you search for particle sprite sheets, you should be able to find quite a few of them. Now, if we play this sprite sheet as an animation, we can see that this looks a lot more interesting than the static image on the left. Okay, but how do we tell our particle system that we want to use this sprite sheet and animate our particles? Well, let's go back to our scene. And then let's duplicate this smoke particle system, Control D to duplicate. And then let's also make the particle process material unique so we don't modify our original particle system. And let's hide the original smoke. And now we can get going. Instead of using the single smoke image, we drag in the sprite sheet. Now our particle system looks a bit funny, but that is because we didn't tell the particle system that we are using a sprite sheet yet. The setting is a bit hidden. We have to go down here into the material section, and then we have to create a new canvas item material. And if we open up the material, we have a checkbox here that is labeled particles animation. So let's check this. And now we get some extra settings where we can tell Godot how big our sprite sheet is. We have 64 frames in total, which is 8 rows by 8 columns. So we use 8 for particles anim horizontal frames and 8 for particles anim vertical frames. Let's also check this particles anim loop checkbox because we want to repeat this animation for as long as the particle lives. If we don't check this, then the animation will only play once. So if we now look at our smoke, well, nothing really has changed. Why is that? Well, we only have set up the animation, but we didn't tell our particle process material to actually animate our particles. We can do this in this display animation section. And here we can change two things, the animation speed and the animation offset. Well, let's start with the speed. This controls how fast the animation is playing. If we hover over the label, the documentation says animation speed of 1 means that particles will make full 0 to 1 offset cycle during lifetime. Now that is again somewhat fancily written, so let's break it down. If we enter a 1 here, then the animation will play 1 full time during the particle's lifetime. So from the start here over the fire to the end here up in the sky, the animation will play 1 time. So let's try 1. But that is hardly noticeable. So maybe a 3. Yeah, that looks a lot better. We can now add even more variety to this smoke by using the offset setting. This tells the particle system where the animation should start. For every particle, the particle system will randomly choose a frame between the start of the animation and its end. And this way, not all the particles play the exact same animation and we get a bit more variety. An offset of 0 means the start of the animation. And an offset of 1 means the end of the animation. For our animation, we don't need very precise control over the offset, so we can just leave the minimum offset at 0 and set the maximum offset to 1. So now the particle system can pick any of our 64 animation frames as a starting offset. And if we put our animated smoke and the original smoke side by side, we can clearly see that the animation is making the smoke a lot more interesting to look at. Using the smoke animation really improved the look of our particles, but that look does not really fit the style of our game. Everything in our game is very flat and simple, and it would be nice if the smoke would match this style. So let's hide this smoke and try to create something different. We start with another GPU particles 2D, and we add a process material, and then we're good to go. I would like to have a few smoke trails that look like this. To achieve this, we are going to use this particle texture, which are just 5 tapered strokes of white with a little bit of blur applied to them. Which texture we use for this effect really makes a huge difference, and this is what I came up with after some experimentation. So as a first step, let's try to get the movement right. Our smoke should not fall down, so let's go into accelerations and gravity and set this to 0. Now we want the particles to move, so we go to spawn velocity and add some minimum and maximum velocity, maybe around 30 and 50. The particles should move upwards, so we change the y direction to a -1. And maybe also let's keep a bit of movement to the right, so it looks like the wind is blowing the smoke a bit to the right, maybe 0.2. Okay, now our particles need a much longer life. So let's go down to the time section and give them a life of about 15 seconds. While we're here, let's also set the pre-process setting to maybe 20 seconds, so our particles are already in full spin when the game starts. Now I think that the particles are spread out too much left and right. So let's go up again here to the velocity section. And then let's move the spread down to maybe 5 degrees. Okay, now we have the movement dialed in, but we want our particles to drag little trails behind themselves, and this doesn't really look like trails. We can do this by going all the way down here into the trails section, and then we can enable the trails here. Now this still doesn't look like trails, so what is wrong here? Well, Godot creates trails by looking at how the particle is moving over a certain amount of time. And then it creates a mesh and animates this mesh rather than just a simple sprite. And with this trail lifetime setting here, we can tell Godot for how long it should watch the particle to create the trail. Right now, this is set to 0.3 seconds, which only gives us these tiny blobs. But if we increase this to, let's say, 2 seconds, then we get a lot longer trails. I think 2 is still a bit short, so maybe let's go with 5. Yep, this looks okay. Next, we have this little ugly section down here. We really want the smoke to look like it comes from the top of the flame and then spreads out over time. And this sounds a bit like scaling, so let's see if the scale settings can help us with that. So let's go up here to display and scale. And here we can set the minimum and maximum scale. But we want to animate the scale over the lifetime of the particles, so we need a scale curve. Let's add one of these. Now we want our particles to start small and become larger over time, so let's use the linear preset here. And this is a lot nicer because now the particles seem to come from the tip of the fire. Let's maybe also increase the maximum scale size so we get a bit more variety with our trails. Maybe let's go with a 3. Okay, that's more variety, but now we get this really ugly zigzag pattern down here. Why is that? Well, when Godot generates the mesh for this particle trail, it tries to use as little geometry as possible so everything still renders quickly. And we get this zigzag pattern because there are not enough vertices in our generated mesh, and Godot can only approximate the trail. We can fix this down here in the trail settings. There's a sections setting which tells Godot how many sections our generated mesh should have. The more sections it has, the smoother it looks, but the more expensive it is. So let's try to increase this to maybe 16. And this looks a bit nicer, but if we zoom in, we still get this pattern. There's another setting called section subdivision, which allows us to subdivide each section into smaller parts. This also adds extra geometry, but this time within the sections themselves. Let's try to increase this to 16 as well. And this seems to work nicely. Okay, we're getting closer, but the smoke should maybe move a bit to the left and the right as it is going up. This again sounds like using a curve, so let's go up here to the animated velocity section. And we want to control the direction into which the particles are moving, so let's go with directional velocity. Let's add a new curve XYZ texture. And now we can create curves for each direction. We only want left and right, so let's add a curve for the x-axis. Now, the curve is always multiplied with the velocity setting up here, so to get a left and right motion, we need to have a curve range from -1 to 1. Now let's add a few points, so our particles can move from left to right, and we need to wait a bit. Well, it seems hardly visible, so let's try to increase the range here, maybe to 30. Wait a bit, and this is better, but all the trails really go very similar paths, so it would be nicer if some of the trails would go into a different direction. We can do this by setting the minimum velocity to a -30 instead of 30. Then some particles will start out in the opposite direction, and we also have a lot more particles that go somewhere in between -30 and 30, so this will give us more variety. Now that is better, but the smoke doesn't really integrate well with the world around it. It should have a more orange color here near the fire, and then become gray and maybe a bit of blue to match the sky color as it moves up. We can do this with a color ramp. So we go to Display, Color Curves, and here we have a color ramp setting. This changes the color of the particles over time. So let's add a new gradient here. And at the left, we want to pick an orange similar to the fire. Well, I think we can just use the color picker for this one. In the middle, we want some gray color. So let's switch over to the HSV section. Bring the saturation completely down so we get a gray value. And then we can use this value slider to set up our gray. And to get some blue back in, we can switch back to the RGB section and just drag the blue slider up a bit. Okay, and now let's add a third step here, where we just pull the alpha all the way down so everything fades out nicely. That looks a lot better, but the trails still somehow pop out of existence at the end of the particle lifetime. And this doesn't really look nice. But why is that? Didn't we just say that the particles should become transparent at the end? Well, they do, but the particle is always at the top of the trail. And the end of the trail is still somewhere here in our color ramp when the particle reaches the end of its lifetime. We cannot change that, but we can change our color ramp so it becomes transparent earlier. And this way the whole trail length has a chance to become transparent before the particle at the top expires. So let's drag this last stop down a bit. And then let's wait for it to stabilize. And this nicely fixes the problem. I think we could use a bit more particles, so let's increase them to 12. And yeah, I think that is good enough for now. As always, we can endlessly tweak this, but this video is already quite long, so let's cut it here. In this video, we learned how 2D particle systems work in Godot. We learned that Godot provides two implementations, a CPU particles 2D and a GPU particles 2D node, and that we want to use the GPU particles 2D node unless we want to develop for very old hardware. We learned that particles are little sprites that are controlled by a particle shader. We learned that Godot has a built-in particle shader called Particle Process Material, which allows us to control our particles without having to write any code, but we can also write custom particle shaders if we need more control. We learned that particles can be spawned in a variety of shapes, like a box, a point, or a ring, and we also learned how we can use textures to define any spawning shape that we would like. We learned that particle systems look more interesting when the particles have a great amount of variety, and we explored a lot of settings to add more variety to our particle systems. We also learned how we can use curves to continuously change settings over the lifetime of our particle. We learned that particle systems automatically disable themselves when they are not visible on screen, and that we can use a visibility rectangle to get more control over this behavior. And we learned how to pre-process particle systems so that they are already in full spin when the player sees them. We learned that particles can collide with our world, but only use a very simplified physics model that can be calculated on the GPU. We also learned that particles do not interact with Godot's physics bodies and colliders, but instead use a light-occluded 2D node for collision. We learned how we can use sub-emitters to spawn additional particles when a particle collides, like the water splashes for our rain. Finally, we learned how to use spritesheets to animate our particles, to get more realistic effects like smoke, and how to use particle trails to create a more stylized smoke effect. Particle systems are somewhat complex to set up and use, but they can really add a lot of atmosphere to a game. We haven't touched every setting there is, but this video should give you a solid foundation for your own experiments with particle systems. We also didn't talk about how particle systems work in 3D and how we can write our own particle shaders. We will have a look at this in future videos. I hope this has been helpful. If you have any questions or want to share some particle system recipes that you have discovered, please post them in the comments. If you like this video, please give it a thumbs up and maybe consider subscribing to the channel to get notified when new videos are posted. Thank you very much and happy Godotneering!